All right, welcome again, everybody. We are on our fifth session tonight, second of the evening. So, and this one should be a exciting one. We've got Steve Beacon. I almost got it. I rolled
You
it
got
out
it.
first. From Dimensional Innovations, who's going to give a presentation tonight on real-time rendering using Unreal Engines. So, with that, Steve, I'll let you give yourself a little bit more of a full introduction, and we'll get this going.
All right, thank you very much. Yeah, as you mentioned, I'm Steve Began. I'm a lead creative technologist and lead for the Tech 3D team at Dimensional Innovations. I'm also a educational content creator at Epic Games. I've been using Unreal Engine for about 5 years, give or take, doing it well for only a couple of years, I would say. But I get to do a lot of work with architecture, 3D design, shaders, materials, look development, VR, kind of all the cool rendering stuff across the board. So I'm very excited. I'm also very excited about Unreal Engine 5, which a lot of people may have heard about recently. There's some really awesome rendering features I can touch on this evening. And I'll focus on Unreal Engine 4, obviously because that is stable. But if everyone here is more interested in hearing about more advanced features, I'd be happy to dive into that as well. I'm going to go ahead and screen share. Oh, there. Can you see my screen okay? It's kind of like flashing black right now.
Yes, we can.
Yes.
Okay. It's like strange. Every couple of seconds it goes black. I'm going to.
We just saw, yeah, it just went black for us too.
Okay. Unreal just crashed. So I'm going to launch that again in the background. Unreal 5 also crashed. Stand by for technical difficulties. Wow, that was quick. Pause my share while I pull this up again. Okay. Wow. I had Unreal 4 pulled up, the project already running in the background. And now it says that I have to reinstall Unreal Engine 4. So I'm going to launch Unreal Engine 5, which is bound to be less stable. I'm so sorry. I'm getting a message saying DirectX is not supported on my system.
As Jeff texted or chatted, it's the curse of
Yeah,
live presentation. So
yeah, I may just need to restart my machine real quick.
Do you want me to pause the recording and take a
Sure.
couple minute break?
Yeah, I'm so sorry. I'll be back in just like one moment.
Okay.
It was fine right before. I'll be right back.
No worries. All right, we are back.
All right, sorry about that technical issue. Here we go. So I'm here to talk about real-time rendering in Unreal Engine, specifically Unreal Engine 4. When I first made this presentation, Unreal Engine 5 had not yet been announced. So at the end, I can go over some of the more advanced features, but we'll start with the simpler stuff. So I'm going to real quickly go over some of the basics and talk about PBR, which is physically based rendering, and how and why we use that in Unreal Engine. We're going to talk about how to create a material, what a material even is compared to textures and shaders, because there's a lot of mixed nomenclature involved with those. And in a material, we're going to add nodes and textures to create a nice wood material, and I'll show you how to make a master material and material instances based on that. After that, we'll talk about iteration and look development and all the different creative ways you can make your own materials going forward. And after that, I'll also go on to talk about lighting, specifically baked versus dynamic, and then also, if there's time, Lumen and Nanite in Unreal Engine 5. So PBR is physically based rendering, and it's a computer graphics approach that seeks to render images in a way that models the flow of light in the real world. So this is a new-ish rendering method. It's not synonymous with photorealism. even stylized games use PBR rendering. Overwatch, Fortnite, they're very stylized and kind of cartoony, but it's still PBR. And really it's just emulating how light works. Even if you have a flying unicorn flying through the clouds, it still needs to emulate how light works in a realistic fashion. So 3ds Max, Maya, Cinema 4D, Unity, Rhino, Unreal, obviously, these all use some form of PBR one way or another. The common types of like material outputs that PBR systems use are base color or albedo or diffuse, roughness, metallic, specularity, normals, bump maps, things like that. So very common terminology between all these different 3D programs. I thought this was really interesting. The minions in Despicable Me, which I think was the first time minions existed, was not PBR. And then in 2015, at that point, they were using PBR. And you can tell like right away, the lighting is so vastly different. And they're the same color yellow, but because of the lighting and the way it's being rendered, it reads very, very differently. Obviously, they're both very cartoony, but the newer version is still much more realistic. I thought this was really interesting. So a lot of people conflate shaders, textures, and materials. And I just want to address this at the start because I'm guilty of this too. And I'm not sure how the terminology is working for Unity, but this is what I found in my research and the correct way to talk about this topic. So a shader is simply a combination of code and the contents of a material graph. So it's just an instruction to the GPU of a computer saying, hey, make this thing appear on my screen. A texture is a 2D image, typically a JPEG, PNG, or TGA, that is used in a material and is mapped to a 3D object. So that is the actual image of wood or bumpiness for wood. It is not the material itself. A material is an asset type created in Unreal Engine that informs how a 3D object appears in the viewport. And that is, simply put, just code at the end of the day. So a texture goes in a material, and a material makes up a shader. So that's kind of like the hierarchy and the nomenclature we'll use going forward. So here are 3 different types of textures: roughness, base color, which is just albedo or diffuse, depending on the program you're in, and a normal map. And you can't really tell, maybe over Zoom, it's very difficult for me to see on my small screen, but the normal map is different colors, and it's not height, like a bump map or a displacement map. It's just informing the direction that light bounces when it hits the object. So then when you see the cracks in the wood here, we're actually able to make the light bounce different directions like it would realistically. So without a normal map or a roughness map, it would just be solid base color. You'd see cracks as just blackness, but it would just be as evenly smooth or rough across the surface. So a few things to keep in mind for textures, specifically in Unreal Engine, and UIs are an exception. They should always, almost always, be a power of 2 resolution and a square or triangle. So that's 64 by 64 all the way up to 4096 by 4096. And there's a few reasons for this. One, you get better and more accurate color representation. Like you see here on the left, this is power of 2, whereas the one on the right is not. This is showing the correct color, and this is a little darker. And I think there's like some levels, gamma issues too. I believe this is due to compression. If someone knows better, please let me know. But as far as I can tell, it has to do with the way power of 2 textures get compressed. Another reason is memory usage. So when you have all of these textures, say you have 500 textures in your Unreal Engine project, those all need to be stored in a efficient pattern. Think about having like a stack of business cards and you have one card that's like index card or like a card turned on its side. It's not going to stack as evenly, and it's just going to cause problems. And the way it gets saved really takes up much more space. So if everything is power of 2, you have more memory usage that you can use. There are ways around that, and obviously better hardware systems is a workaround as well. And another reason is MIP maps. Is anyone here familiar with MIP maps or MIP generation? I'm not sure if there's a different term in Unity. Joel is nodding his head. That is a good sign. MIP maps are basically smaller versions of the same texture that are taking up less space, and they are more memory efficient. So if you have this 2048 by 2048 texture, Unreal Engine would also generate a 1024 by 1024, 512 by 512, 256, 128, 64, and so on. Reason being, if you are rendering this wood sphere 20 meters in the distance, you don't need to see a 2K by 2K resolution texture. You can get away with a 8 by 8 pixel texture because it's 2 pixels on your screen. So when we're able to dynamically stream in those different textures, which Unreal does automatically, then we're able to use memory more efficiently and have ultimately better resolution in our scene. I've also noticed that if you don't have MIP maps, then you can kind of see it on the screen a little bit, but textures off in the distance, because they're staying at their highest possible resolution, they have horrible aliasing. And I've noticed this in VR a lot, and it's been extremely annoying to me. Once I figured out the issue I caused, it looks so much smoother and performant when you use Power of 2. So that was a lot of information very quickly, and it's stuff that frankly I wish I knew like 4.5 years ago. So I'm going to take a couple seconds there, and I'm going to launch my project in the meantime. But is there anything anyone would like me to clarify regarding all of that? Share, I'm just going to launch this in the background. I apologize if you can hear a child screaming upstairs. Partially my fault. Okay, so next we're going to talk about master materials and material instancing. And once I have my Unreal Engine project pulled up, there we go, perfect timing, more or less. Here we are in Unreal Engine. This is a simple demonstration level I created. These 4 materials are based on a single master material or a parent, and they're just different instances of the same thing. So just as a quick demonstration for making a material, if we right click down here in the content browser or go up to add material, we can make material. I'm going to call it M_KC test because I'm very creative this evening. And we double click that, we see the material graph. We have our details panel over on the left with all of our default settings, a nice little viewport in the top left, and then all of the magic happens here in the right in the node graph. So our outputs are base color, metallic, and so on. These are all of our basic PBR options. This evening, I'm only going to focus on base color, roughness, and normal. These are the most common that we tend to use, so we're just going to focus on those. So I went to a website called freepbr.com. You can download a bunch of textures for different realistic materials. I got this bamboo diffuse, bamboo roughness, and bamboo normal, which I swear has a little bit of variation to it, even if you can't see it over this recording. So I'm going to simply drag bamboo diffuse in here, bamboo roughness, and bamboo normal. Make this full screen again. And I'm going to plug my RGB of my diffuse into base color. I only want a single channel out of my roughness. I'm going to pull the red value to roughness and RGB of normal to normal. And when I do that, I always feel like I'm teaching my infant how to like draw within the lines or use crayons or something, because it is so simple, but it looks so good when it's done. And there's a small delay here. In Unreal Engine 5, this is much quicker, but right now we are compiling shaders, as you can see in the top left. And what this is doing Unreal is calculating every possible permutation of this material as it may be needed in the project. If I went in and disabled mobile shaders or shaders for particle systems like Niagara, then it would go quicker. And also if you have a better CPU, it'll go much quicker. But this is finally done, and we can see a nice bamboo material here in the viewport. If I zoom in, you can even see some of the bumpiness between all of the cracks, and it looks perfect. It looks kind of wet, actually. But it's fine. It's good enough as it is. If I save, it'll commit these changes, and then I'll be able to add it to a material, or excuse me, to an object. Make another sphere here, my KC test here, and there we go. We even get some nice reflections of these other objects here showing. It's very nice. So next, let's make this quicker to edit. Say we want to have a few different variations of this bamboo wood that are maybe slightly different colors, and they have a little bit different roughness value. I'm going to double click this material again, go in here, and let's make a simple addition here. So instead of going straight to base color, I'm going to drag out from here and type multiply. And this is just going to be a simple mathematic multiply. We're going to multiply the RGB value against a constant free vector. And this is just going to give us an RGB. So it'll be this red multiplied by this number, the green, this number, blue, this number. Right now it's defaulting to black, which is 0, 0, 0. I'm going to make that white. And next I'm going to right click this and convert to parameter and call this color multiply. Very creative. Plug that into the base color. We could also, for example, do RGB and do an add, or we could get really crazy and take another texture and take like a, what is a good example? This weird, I have no idea what this is, a little green face, and multiply that against the RGB values of this, and we would get some funky looking wooden face texture. Next, I'm going to just move these aside out of the way. I'm going to take this roughness. Let's we'll make a more simple parameter. I'm going to right click and type constant. We can get a constant single value. Right click this, convert to parameter, and we'll call it roughness. Default to 0.5. Plug that in here. Okay. We can see in the bottom, every time I make a modification, it's increasing the amount of shaders. I feel like it's always a race to see if I can finish my stuff before that changes, but it always just goes higher. I could also make a different setting here. We could drag out from the RGB and make a flatten normal and then flatten it by a certain value, but that'll just increase time. But that would be a way we could reduce the amount of normal that we have. We could even take this texture and right click, convert to parameter, so then that can be something we edit in real time. So I'm going to let that do its thing, and I'm going to show you a different material I set up ahead of time, just to save us a little bit of time. So this master material has a parameter for the base color, metallic, which by default is 0, specular, which default is 0.5, roughness 0.5, emissive color, which is 0, 0, 0, because we do not want it emitting light by default, and then a normal texture that can be flattened. So if we close out up here, we can see this is exactly what that looks like with 0 modification. If I were to duplicate this, and then I'm going to make another instance, if I go to the master material, right click, create instance, I'll call this MI KC test 1. That's on here. No change initially because we haven't changed any of those parameters, but if we double click that material instance, open this up, get a little bit more room here. Now we have a little checkbox for each of those parameters that we had created. And we can change these in real time and see different change. So let's say we want this to be, I don't know, I'll choose a gross color. Ooh, that's a good one. Yep. And then let's make this metallic, not rough. There we go. A nice green metallic ball. Let's say we want, let's say we're working on a project and we want a slightly different metallic ball. We have the exact same settings on here. We have a different instance. If I open this, let's say we wanted, actually wanted this to have a little bit of a normal to it, and then maybe just tweak the color a little bit. So maybe it's related and we use them for different objects in the scene. And because these are part of the same master material, as you can see down here, MM sample master, if I were to go in here and add some logic where maybe there's information, a blended texture going to the roughness, it would apply to all of the children down the chain. So all of these 6 materials on the bottom here, they're all based on the exact same master material. I could change a default here and it would propagate to all of the children and save us so much time. I've worked on a lot of projects where I have a couple hundred materials and I have one very complex master material that is kind of the root of all of the other ones. And because that first one has all the complexity, it's so much easier to just iterate and make something look really nice very quickly. Okay, anyone want me to elaborate on anything pertaining to parameters, instances, master materials before I move on? All right.
You missed your joke opportunity though, because I was going to say, you know, when it crashed, those were the children that were screaming that we were hearing on the background, right? Sorry.
Yeah, think of it this way.
Couldn't resist.
That crying child is an instance of my self, I guess. Can you hear him though?
No,
Okay,
we cannot.
cool.
Yeah,
Okay.
you're good.
He's not crying then. Yeah. Okay, so this is a wood material, a master, and then an instance of the same thing. If I open this wood, all the only change is we have base color multiplied against a constant 3 vector, like we talked about before. If I change this value, we get a colorful wood. So we could have any number of these throughout our project, and because all of that logic is only happening one time here in the master material, it is extremely performant to do things this way. It also looks very good if you do things right.
Wait, so you're saying that there's a basically nested materials?
Oh, yes.
Oh, okay. That's something that Unity won't do. They said like, oh, we haven't figured out they've got nested prefabs now, but they won't. Like, well, we still haven't figured out how the how the variants and all that would. That's how they would probably do that. People have been asking for variants.
Interesting. Joel, I know you have some experience with Unity. Can you speak to the correlation between the two? Have you had any luck with anything similar in there?
You know, I've been working in Unreal now for the last year, and I'm trying to think of the correlation. I definitely like the material instancing in Unreal. I'm trying to think what that correlates to in Unity. I think Jeff's right. I think there's not they certainly don't have the material instancing like that. So,
that's interesting.
There's some kind of reuse, but that's
Gotcha.
no, it's not as slick as Unreal.
Yeah, that's really one of the biggest advantages for me. It's very much made for artists and people who don't come from a developer background. So if you just want to make something look good very quickly with very little experience, frankly, you can do it very quickly. So that's been very nice for me.
Yeah.
Well, there's always I just saw this tweet this last week that there's an incongruity between like the models and the materials, though they seem mismatched, and you don't typically see that in Unity. That's somebody Anton was saying that Anton Hand like yeah,
From, hot dogs,
Yeah.
horseshoes, hand grenades. Yeah.
yeah, he just said that like this last week. I was like, yeah, I guess I've probably seen a couple of games. There's one of the other differences like this is I don't think you see very many games that are two-dimensional. You see 2.5 dimensional games in Unreal, but most of those get made in Unity.
Yeah.
One of the big differences.
Definitely.
It'd be nice if they would get some tools to be able to much easier. What is it, Flipbook or what was that? Yeah,
It's a paper 2D. Is that render system, I believe, in Unreal. Flipbook is more 2D animation.
oh, okay.
The way that has to be set up. I honestly have never made 2D content in Unreal. I've also never really thought too much about it, but now that I think about it, I haven't heard of any efforts, frankly, to make more accessible tools for 2D applications in Unreal.
It's because they would have to be competing with Unity, and Unity
Exactly.
owns the market on 2D games. It's like phone games. They like. I guess there's some AAA that were Unreal on phones,
Mhm.
but
Mhm.
anything else, and it's like there's this YouTube video. It's like it's titled Unity, good enough for bad games. It's not. It's like not saying that Unity games that are made in Unity are bad. It's just that if you're going to make a bad game, you're probably going to make it in Unity because it's easier to get into.
Yeah, it's very easy for smaller teams. Very easy to make stuff quickly, and the program, as far as I can tell, is much lighter.
Oh yeah, you can create like 3 or 4 instances of your editor, and then but Unreal, people are like, I can't even do 2.
Yeah.
Yeah.
Yeah, you saw how hard I crashed at the start of this presentation.
Oh, dude, I put in the messaging chat. I was like, I was going to do the Unity presentation in Unity. It's like I know it would have crashed. It's like,
Yeah.
You just know that curse of live presentation.
Yeah, I've given a few presentations in Unreal as well, and that's always like the biggest concern. Like I know the slides are fine, I know like my hotkeys are working. It's just relying on that variable. It's hard to control, for sure.
I think they copied the orange outline for an object. Now, yes, that is like when you select some objects. This is the one that's selected. It's like basically the same thing.
Mhm, mhm.
And then I guess the other Unity copied by acquiring Bolt and Bolt 2, the blueprints. They're trying to make their own blueprints. That was the one thing. Like I think the reason that people choose Unity over Unreal most of the time is that the first programming language that they were taught was JavaScript. I think that was like a lot. Like that's probably one of like the easiest, not low level language, but
More accessible than others. Yeah. Mhm.
but then that's easy to transfer over into C#, and then of course
Yeah.
C++ being kind of of course that's why they made blueprints.
Mhm. Yeah, and if you think about it, if you are the type of person who wants to make a game or a software application, odds are you already have some coding background. So if you're looking for a program that appeals to coders, Unity is probably a way to go. It definitely makes more sense in a lot of applications. It's interesting to see the differences in visual style that people are able to achieve between the two programs, for sure.
Yeah, well, I've seen somebody do a like they had like challenged themselves. They made a game that will look identical. They just like, I want to see
Really?
make this scene. I want to see if I can make it look identical.
Yeah.
And like I'm really curious. Like, okay, so you said one of your slides had nanite on it. Okay, there was this rendering engine that was like infinity or unlimited polygons. So they're not them, but this Euclidean engine, I think was what it was called. This was like maybe more than a decade ago, and they basically had this thing where what it sounds like nanite, but I don't 100% sure. I'm very curious to somebody inside of Unreal to like, can you tell me if, because I know that when they first put out that nanite demonstration, the one with the girl walking through the cave, I was like, startled at how different, like, okay, this looks photoreal, the world looks photoreal, but then the character didn't look like that, like there
Yeah.
was some indiscrepancy. I think they fixed that with that new one that they just released, that new template or whatever that they just released. That looks very, very close, but like the visual fidelity between those. But so the problem that Euclidean had was that they couldn't animate things. And that's what I'm curious if Nanite can't do.
So Unreal 5 is still early access, right? And one of the limitations for Nanite is it does not work for animated textures, morph targets, even static meshes that do have any sort of world position offset or displacement on them. As I understand it, the character they created for the Unreal Engine 5 announcement video, that was probably more of a realistic, stylized sort of dramatized person, so that they could highlight the realism of the environment more and also not focus on the person not being photorealistic. Obviously, Metahuman,
Photorealistic.
yeah, looks
Yeah, sure.
phenomenal, and that has its own issues, frankly, right now too. So I have no concerns that they'll be able to get there. I think it's just that where Unreal Engine 5 was at that point, it was like, if we try to show animated people with full like realism, it's gonna like be an uncanny valley thing. So
I get
yeah,
it.
yeah, but I'm sure it'll do better. There's still a while until it releases. So let's get through baked versus dynamic lighting, and then we can dive into Unreal 5 stuff. I want to do that last because I know something's going to crash, because early access is always fun and risky. So for anyone who does not know already, you can bake lighting in Unreal Engine. It has its advantages, but there's still reasons you should use dynamic lighting. And strictly speaking, Unreal Engine 4 here and non-real-time ray tracing, which, by the way, RTX in Unreal 5 is deprecated because Lumen surpasses that. So I'm just going to skip over real-time ray tracing entirely here for a couple minutes. This is an example of baked versus dynamic lights. Any light here that we have, spotlight, point light, rectangular light, and so on, can be static, stationary, or movable. Static lights are completely baked, whereas movable lights are completely dynamic. And this movable light here, these two have the same lighting settings, same attenuation, radius, brightness, and so on. If I rotate this movable light, we can see it's casting a nice crisp shadow along the edge of the box, and we get a really nice smooth fall off on the box itself. However, because it's not baked, we're not seeing any change in brightness on the side of this box here. We would expect if we had a spotlight shining right here and it's just like blowing this up, we would see some bounce lighting here, right? But dynamic lights in Unreal Engine 4 do not count bounces. So this static light, as a difference, I'm going to switch to a detailed lighting mode. We can immediately see a difference in resolution. And this has to do with the static mesh light map resolution on the box itself is smaller than it probably should be. This is totally smooth, being calculated per frame, and this is just calculated once. And then this is also getting a nice diffused fall off with the shadow. And it's also, we can't really see anywhere here, but it is calculating, I believe, 5 or 10 bounces currently. So static lights tend to offer better realism. I always keep my sunlight, especially for exterior scenes, keep that as dynamic, and all of the other lights that can be baked, I keep those baked as well. And this one, whereas we could rotate it and see like some slight changes, maybe the creative director says, oh, it looks good, but turn it a little bit, make it, I don't know, purple for reasons. This one, as soon as I move it, is no longer baked. And we get a nice watermark back here saying preview. So that could be a problem. And then they say, oh, well, change the color. And well, now we need to bake the light before we actually see a good, precise result. So there's advantages to both. And I believe you can do some light baking in Unity as well. But This is a good quick example of it in Unreal. Anything anyone would like me to cover pertaining to baking, lighting, for just build that. This all happens on the CPU. There's an experimental feature currently where you can build your lighting on GPU, which I gotta say is for me 100 times faster than CPU. And you can actually do it and see progress bars on each mesh as the light builds. It's phenomenal. I'm so happy with it. But again, lighting is all changing in Unreal 5, and light baking is, oh yeah, here we go. You can see the bounced purple lighting is affecting this entire area because of how bright it is and colorful. That is gross color. All right, I'm gonna launch Unreal 5. Fingers crossed. Oh, fast here. Another thing worth talking about is UVs. In Unreal, the first UV is typically used for materials and the second used for light maps. This is a really good graphic to communicate what exactly a UV is. To me, it's the most complicated topic in 3D to really explain and understand because there's like no really good documentation for it. In my experience, like looking at the Unreal Engine documentation, it says like, oh, you want your UVs to be good and clean and not bad. Great, that's nice. I see the UVs you made look phenomenal. Your lighting looks nice. How do I make that? It is a very complicated topic. There is better training resources on Unreal Engine's website now for learning how to do good UVs. And there's also tools within Unreal to create your own unwrapped UVs in the editor itself. So that's much easier now, much smoother. All right, welcome to Unreal Engine 5. I'm gonna open up a exterior lighting project here. Has anyone else poked around in Unreal 5? Joel, you have not. Oh man, I'm glad I get to be the one to show you. So happy. All right. So the first thing you'll notice is a UI refresh. It kind of reminds me of switching to Adobe CS6 when that came out, and it's a little bit darker, much crisper. A lot of features are kind of like put in little folders now, and we can keep these to the side if we want to, but it's all contextual. The content browser auto hides. If we hit Control Space, we can show and hide that. We can also make it dock to the bottom if we want to. In my experience so far, this is much better on a 2-monitor setup, and I'm only doing this on 1 monitor, so I'm getting better performance, that's for sure. So this is a quick scene I set up using some nanite meshes and some nice lighting. All of these photogrammetry rock scans are from Quixel, and they are crazy high resolution to the point that if we get really close, we can see even just like little specks of detail on here. If we switch to wireframe view mode, they show us like these little ghosty objects, presumably because the polygon count is so high. I'm going to go to lit mode up here, go to nanite visualization and show triangles. And this shows every polygon on those nanite objects. So if I move in really close here, we can start to count all of these triangles. But if we go out, way out, way out, at some point, each triangle is on its own pixel. And there's even some shimmering happening on my screen because there's multiple triangles fighting for pixels. So I'm sitting at 45, 50 frames per second right now. It's running nice and smooth, very little issue, 30 frames per second, real-time lighting. Let's talk about lighting. So Lumen is the name of the new lighting engine that we're using here. and it is providing real-time dynamic global illumination. And it's much more precise and applies to all of our dynamic lights with much better performance. Currently, I have two lights in the scene. I have a skylight and a directional light. I'll hide them one at a time so you can kind of see what they're doing. That's the skylight. This is the directional light. Takes a couple of seconds to cache some of those frames. And then the water, this is just a panning normal on a plane. So it's very low poly. Looks kind of complicated, but it's not. And the nice thing about the exterior lighting system, we're using volumetric clouds that are moving in the wind and the global atmosphere fog. And if I just rotate my sun, we can see realistic fall off behind the clouds, realistic sunset, and the clouds go away. Bring the sun back over here. Let's see, nice time of day transitions. All happening at a good, smooth 40 or so, 50 frames per second. If I fly the camera, we can have some pretty massive worlds without much pitch. Oh, speak of the devil. This is a whole small island I created using World Creator with some giant nanite meshes here, just to show the complexity of what we can do with sky atmosphere. If it's ever going to crash, it's going to crash right now. I'm going to change my camera speed to something astronomically high, and we are going to blast off. Yeah. We are flying straight up through the atmosphere as fast as our little Unreal camera will allow. Presumably passing the, yep. I believe that is my sky dome. I'll hide that. And we can see the actual atmospheric fall off of the planet being rendered in Unreal. So now if I were to rotate our sun, we can see actual atmospheric fall off. Some fun glitching here. And we can even control the amount of smog in the atmosphere, the color of the gases that are absorbing and reflecting light, the overall color of the albedo of the ground, the width of the planet, the radius of the atmosphere, all at a good, nice, smooth frame rate. Go back home. Let's get some more light in here. There we go. And then I added a nice low poly cat just because cats always make content much better. So I will leave it there, save 10 minutes for some Q&A and go over any other topics you would like to talk about. Thank you.
And you didn't crash.
I did not crash, not even once. You paused the recording before, right? I didn't crash at all tonight.
Never happened. Yeah.
I got the recording.
Yeah, that was my gizmo breaking up, and my frame rate was as soon as we get the entire landscape in here, it's dropping down to 20, but still pretty smooth overall. I'm not sure what the compression looks like over Zoom. I'm sure it's not great.
So does Nanite sort of LOD?
Yes. So if we were to, oh, also nanite meshes don't need explicit levels of detail. Nanite covers all of that. So I believe if we go to cluster, it takes all of those groups of triangles and groups them together. So at a distance, you can see them popping together in different groups. So it's essentially the same idea as LODs, except more of an attention on per triangle instead of just whole objects.
Have you tried it in VR yet? Any, what kind of
No,
frame rate?
sir. I have talked to some folks from Epic about it, and the official documentation says mobile platforms and VR do not support Nanite or Lumen. However, I've heard that you can get it running in VR, but it only renders to one eye. So,
Oh, because they only single pass, right? You want it, yeah. So
Mhm.
that's probably
yeah, early access is
yeah.
fun. It is what it is.
Well, whoever would be developing it with that before, they would have broken it multiple times. So of course they're not going to say, "Yeah, this is how you should do it." But we're
Yeah, it's pretty amazing to me how quickly they were able to make these features, and of course, I'm sure they were in development for years upon years. But
6 years probably.
yeah, just seeing the progress and how quickly the team at Epic is able to launch and support new features has been really nice to see.
It's really cool when the sun goes behind the clouds.
Mhm, mhm. Yeah, and we get shadows through and under the clouds as well. Yeah.
Yeah, I hope the dude who created, what was that? It's not Rocket League. What's the game? It's a VR game where you shoot hook shots. Jet Island. He was trying to get basically like what you're showing here with the like God rays. He wanted
Yeah, and it's interesting. The volumetric cloud is all driven through some parameters, just like our wood material before. I am not very good at figuring out what exactly they do, but it's fun to mess around and get some strange results.
those will be our human beings' final last words will be, "Oh, it worked," or "What was that?"
Or I'm not sure what it does, but it looks pretty.
Yeah, yeah. I like taking things apart and then like it's like, oh, I can make it do this thing. Like I with the visual scripting, I've made like a flying soccer. Like they weren't supposed to be flying, but that's how it happened.
Interesting, yeah.
Yeah.
And then you made a whole new game type just by accident. Ooh, there we go. This is like a nice
Kind of
Goonie
stylized.
style.
So
Yeah.
can I ask being a very non-technical person, what may be a very stupid question, but
Please.
No stupid questions, only stupid answers.
yeah, if we're using object, I mean, can a lot of this rendering be applied if you're doing object tracking? I'm thinking specifically of a couple of the projects we're doing that people are wanting, doing augmented reality overlays on an actual object. Would this rendering work for something like that?
Um, so you're speaking more about projection mapping?
Well, I'm saying
Or-
so.
oh,
Specific,
AR
I'll tell
tracking
you.
too.
Let me give you a specific
Sure.
one of the projects. We're doing this animating a mannequin. So we're doing object tracking to walk onto an actual mannequin. We want to overlay, realistic face and facial expressions and scars and bruises. Would you be able to render something like this in that type of application?
Definitely. I would not recommend Unreal 5 for anything that you are hoping to launch on any type of device in the next few months. But in Unreal Engine 4, yeah, you could use AR markers to track on objects that have a material of anything, really. Yeah.
Right.
Mhm.
Okay. Thank you.
So there's no package that or whatever that they would have that would help them in doing that, but they have to make it themselves.
There may be content on the Epic Games Marketplace. I know there's some content pertaining to AR and using AR trackers.
Are you talking about fiduciary markers?
I believe you can do that, or you can do like tap to place. And I've seen some
okay.
Unreal content that speaks to how to do that. But I have used object recognition for in Unreal for AR. So you can have it track an image or a 3D model. It's just looking for an image of the model, really, but there's multiple methods for that. It's been a while though.
Push a little further too, because you briefly mentioned, could you use MetaHuman Creator?
Oh yeah, sure.
Definitely, yeah. I'm not sure.
Lower the quality.
Yeah, so MetaHuman Creator does come with pre-made levels of detail that should run on mobile devices, is my understanding. I don't have any insight as to how performant it is, but that's also an early access feature. So presumably, yeah, you could track a face. I know I've seen actually examples of using AR with a phone to see a person in a space using mocap that way.
Okay.
Yeah, and face this full facial control rig that you can control from an iPhone with the depth camera on an iPhone. So there's seen some pretty slick stuff.
I would suggest MakeHuman for at least for the creation instead of Meta, because even with those LODs, it might still not be low enough.
Yeah, the MetaHuman is phenomenal.
Yeah, it's insane. I really wish I had a better grasp on face tracking and motion capture. My biggest concern currently, and the reason I don't use it for populating scenes with people, is it seems like the proportion of the body to the head is a little bit off. And I can show you here in a moment if we have time after this connects. But it seems like the head is a little bit too small for the body. Feels like a little bit that it's like kind of makes you think, and you can immediately recognize that it's a early access application.
So if you're only wanting to do heads, though, it may really be a good app.
Exactly. Yeah.
Scale to your needs.
Custom made. Well, that's loading. We're right at the top of the hour, and we're about to start going to the third presentation, even though we're not being held up by Andrew London. As I said, I'm doing a recording on it. But so any last questions before we let Steve go and move on? Yeah.
This is disturbing. The eyes make me feel like Sims, but like if you put your hand over the eyes, it's like, oh, okay, that's just a person. And then the eyes just kind of creep me out. Like, no.
Pretty incredible.
No.
Oh, yeah, the expression.
And this will get better. This will get better too. This is, like you said, it's early access, so it's be some good times ahead in Unreal.
Yeah, it's stunning.
Very, very interesting. Well, Steve, thank you so much. It was a great presentation tonight, even with the occasional glitch. Still, everything flowed well. We appreciate it. We appreciate the time. And
it's nice to finally meet you. As many times as I've heard you mentioned by Andrew London.
Yeah, you as well, Jeff. And I'm sure I'll see everyone around as things start returning to normal. And thank you everyone for taking time. It's always tough on weeknights. There's always a lot going on, so I really appreciate it.
Yeah. Thank you.
Thanks for the UE5 tour. Finally get to see it. Get in there.
Are your socks blown off? Yeah.
I am.
Oh, and I think the reason that the minions look much different in the second movie is because of subsurface scattering, not because
okay.
It doesn't make it different. I think if you're going to give this presentation again, I would change it to something that instead of wood with maybe water on it, because that would because the difference in the material would be because you want to show not a consistent thing among it, something that's much different for that So yeah, some wet material would be what I've seen with Unreal, like coming out of the floor is like really good examples.